This is part 3 on our discussion of pH and pOH. In the previous video, I have discussed that pH is equal to the negative log of the concentration of H+. It's also similar, or it's equal also to the negative log of the concentration of hydronium ion. So again, this hydronium and H+ are used interchangeably. We also have the pOH. pOH is similar to pH, pero instead na H plus ang concentration, it depends on the concentration of the hydroxide or the OH minus concentration. Let's go back to the dissociation of H2O. This one is the simplified equation for the dissociation of H2O into ions H plus and OH minus. Again, this one is the equilibrium expression for this reaction, and we know the constant. The constant is 1.00 times 10 to the power of negative 14, and we can say this is equal to this one. Let's say we want to get the negative log of all the numbers here. We can have this one, so I just get the negative log of this one, and then this one, and then this one. So of course, the negative log of this number is equal to 14. And here we have the negative log on the concentration of H3O plus. Again, this H plus and then this H3O plus, these are the same again. So here we have the negative log of the concentration of hydronium ion. Of course, this one is our pH, right? And then this one is our pOH, the negative log of the concentration of OH minus. Again, this one is the pOH. It's equal to 14. So please remember this one. The pH plus the pOH is always equal to 14. Let's use this one in completing this table. So we have here the concentration of the H plus concentration. Again, it's similar with the hydronium ion concentration. Here we have the concentration of hydroxide ion or OH minus. Then here we have the pH, the pOH, and then here we have the classification of the substance, whether acid, base, or neutral. For the first one, given is the concentration of the hydrogen ion, which is equal to 1 times 10 to the power of negative 7. This is a familiar number because this one is the concentration of H plus in water, and of course water is neutral. And of course, in a neutral substance, the concentration of H plus is equal to the concentration of OH minus. So we also have 1 times 10 to the power of negative 7. Let's determine the pH of this one. Of course, the pH is equal to the negative log of the concentration of H plus. And here we have the given na nga to ang H plus, so we can put it here on the equation, the negative log of 1 times 10 to the power of negative 7. So this one is an easy number because it's base 10, then here we have the coefficient is 1. We can determine that the log of this one is 7 or negative 7. So, and of course, since it's negative, so the negative of negative 7 is 7. So the pH for this one is 7. And then we also need to find out the pOH. The pOH depends on the OH minus concentration. So again, the pOH, that's very similar to pH, pero instead na H plus yung basis, the basis will be the concentration of the OH minus or the hydroxide ion concentration. Here our concentration is 1 times 1.0 times 10 to the power of negative 7. And this one is the same with this one, right? So this is also equal to 7. So the pOH here is equal to 7. And of course, the pH here is 7. This one is obviously neutral. And please remember that pH, again, the sum of pH and pOH is equal to 14. So obviously here, 7 plus 7 is 14, which is correct. Let's go to the next one. The given for the second one is the pH, which is 3.50. From this, let's find out the pOH first. Again, the pH and then the pOH is always equal to 14. So if we know the pH, again, that's 3.5, we can determine our pOH. because again the sum is always equal to 14. So to find out for the pOH here, simply subtract 3.5 from 14. So just transpose this one over here. So we have, let's open our calculator. So we have 14 minus 3.5 is equal to 10.5. So here the pH is equal to 10.5. The pOH is equal to 10.5. We have the pH, then we have the pOH.